Hey Team Bio, welcome to a screencast, Understanding Simple Code. I'm going to take the code that we looked at in class today and just run through it line by line and explain what's going on. Okay, so first of all, brief review of functions and variables and explaining a little bit more about what they do in the code specifically here. Okay, so you know a function performs an operation. Functions can be native. This means that they're pre-built into the code. Or they can be user-defined. Written by you. We're going to start out with native functions, just using the built-in functions, but later on in the semester, we're going to start writing our own functions. You can recognize a function because it's going to have a pretty specific structure. It's going to have a name. And this function, its name is function name. It's traditional in lots of coding languages to write words in all lowercase, but if a word is, or if a function or a variable is a compound of two words, you can't include a space because then you'll get an error in your code, but it's traditional to capitalize the first letter of the second word. I think just so it's easier to read. Okay, so a function is going to have a name. You're going to write it down, and that's calling the function. Then there'll be a set of parentheses, and the function may have arguments. Arguments are separated by commas. And then we end the parentheses here. Arguments are info required by the function. To run the function. So some functions have arguments, others do not. The function ends with a semicolon. Another structure of a function that you'll see as well is the function has a name. It has parentheses. There could be something in these parentheses, or there could be nothing in these parentheses. And then instead of a semicolon, there is a set of curly braces, and then there'll be some more lines of code here. Here's another function with a set of parentheses, and then a semicolon. There might be multiple other lines of code, each ended with a semicolon, and then a curly brace to finish this function off. So if this function fully runs, it'll run every line of code up until the end of the parentheses. Okay, so two ways you can recognize functions. They might look like this, or they might look like this. Variable. A variable is a way to hold or store information. All variables have a type. And the type determines what kind of information can be stored. All of the variables in our programs are user-defined. So you write them, oops, there's me in there. You write them yourself. It's a good idea to give them a title that makes sense. They're storing information, so it's a good idea to give them a name that reflects the type of information that they're storing. Okay, and then sensors, you know that sensors are when you have a physical input, you get an electrical output. An example of that would be a button. We always read sensors and they're always inputs. Actuators take a electrical input and they give you a physical output. So an example of that is the light. We've got electrical current running through the LED, and we always write to them. And they're outputs. Okay, so knowing all that, let's move on down to our code. The first line of code is a user-defined variable. The type of this variable is int. This means that it's an integer. It can only store whole numbers. It can't store decimals. I called, when I wrote this code, I called this button state because this integer I'm going to use to store the state of the button, whether or not the button is pressed. You don't have to do this, but sometimes it's helpful to give the variable a initial value, and I've given an initial value of 0 or low. So this just means the first time the code runs, the button reading is 0. Like when the program starts, the button state is storing the value 0, which means that the button is not pressed. Oops, there's an R in here, integer. Good, okay, so that's the first line of code. This is a user-defined variable that I wrote. It's going to store the value of the buttons. The next piece of code is the setup. This is always going to be part of your code, and as you know, it's a function that runs one time. Pin modes are native functions. They're built in to the computer, and this tells your Arduino what's hooked up to your input-output pins. So right now, we've got wires connected to 2, 3, and 4, and the button is connected to pin 2, and the LEDs are connected to 3 and 4. So we have to tell the Arduino what pins is it going to be reading and what pins is it going to be writing to. And we do that by declaring pins 3 and 4 as outputs for our actuators and pin 2 as our input. So pin mode, this native function, takes 2 arguments. The first argument is the pin number, and the second argument is input or output. And we have to tell the Arduino what pins we're using. Okay. So the setup is a function itself. You can recognize here the structure of, we've got these curly braces here and here. So when this function runs, it's going to run through all of these lines of code. Pin mode is a function, and the function ends with a semicolon at the end of each line. Okay, great. Now we move on to the loop. And this function is going to repeat itself over and over again. Looping function. I read on the internet that it can loop, if the loop is totally empty, it can loop as many times as 4 million times per second. So the loop runs really quickly. The more you put in the loop, the slower it runs, because the computer takes time to move from each line of code to the next line of code. Okay, so the loop function starts here with this first line. Here we have our variable, button state, and we're setting it equal to the digital read of pin 2. This is a native function. And this digital part of the function means, let's start with the read part. We're talking about a sensor here. Pin 2 is hooked up to a sensor. And so we are reading our sensor. Now the digital part. Oh, I think actually we will have talked about this in class already when you watch this, which is good. Okay, digital in Arduino language means that there are 2 possible states. on or off, 1 or 0. These are equivalent statements. So digital is binary. There are two possible conditions. Because we're talking about a button here, the button only has two possible states. It can either be pressed or it can be unpressed. If it's unpressed, then it's off, and the reading on the button is going to be 0. If the button is pressed, it will be on, and the reading on the button will be 1. Okay, let's talk about this equals statement for a second. This equals statement, let's say we have the condition A equals B. This equals sign is called an assignment operator. In computer language, it means set A equal to the value of B. So when we performed a digital read of pin 2, whatever the reading on the button was, if it was 0, if it was unpressed, then our button state took on a value of 0. If it was pressed, then the reading is 1, and the button state took on a value of 1. I guess I should also say this is 1 or high, and this is 0 or low. These are all equivalent statements. Okay, let's move on to the next line of code because this semicolon ends our function. Now we have an if statement. If button state equals high. This equals is very different than a single equals sign. A equals B is an equality operator. It essentially says, okay, I'm going to write this down first. It returns true if A equals B. What does that mean? Well, it's kind of like the computer saying, check to see if A is equal to B. Okay, so there are two possible situations here. Either A is equal to B. If A equals B, then the statement is true. If A does not equal B, then this statement is false. Okay, so here we have if button state equals high. This is saying, is the value of the button state equal to high or 1? So our digital reading of our button state could be either a value of high or low, 1 or 0. If the button state is equal to high, then this code block will run. If it's not true, then this code block will be skipped, and we'll move on to the next line of code following the end of the curly braces. So this only runs if this is true. Yeah, okay, that was actually a pretty good way to write it. If this is true. If it's false, we go around the last curly brace and we proceed on to the next line of code. This next line of code is the same kind of logic except checking for the opposite condition. If the button state is low, then we will perform this line of code. Okay, last little bit of the code here, digital write. It's similar to digital read, but now we're talking about an actuator. So we're going to write to an actuator. And digital means that it's two states, either on or off, high or low. So when we digital read pin 2, we were looking at the sensor and seeing if the button was pressed or unpressed. With the digital write, we are going to send a command to an actuator, the light, and turn it on or off. So the two arguments within digital write are the pin number and then either low or high. If you write low, then the light is turning off. If you write high, then the light is turning on. You could also write 0 and 1 here, and that would be equivalent statements, and that would work just as well. Okay, so, and then I guess I'll just say digital write, this is a native function. It's a built-in function in the Arduino. Okay, I think that we have gone over all the code, all the important parts. The last thing that I want to just quickly chat with you about is the code syntax. So this is like computer grammar. It's the fact that to call this function, you need to capitalize the W. If you write this all in lowercase, then it's not the correct syntax. You need to separate your arguments by parentheses, and you need to end a function with a semicolon. You need to have opening and closing curly brackets for every function, including, here we have the opening and closing function curly braces for the loop. If you have an error in your syntax, then the code's logic or meaning could be affected. So maybe you're not actually getting the computer to do what you want it to do. And you also might write code that has an error and won't run at all. It seems kind of daunting if you're just starting out getting all the syntax correct, but trust me, over the course of the semester, you are going to become a pro at C++ syntax. So that's all. Okay, bye.